Hey everyone, welcome to Lab 7. So we've got quite a bit that we're trying to accomplish here today. So let's take a look. Excuse me. So today we're going to go over again how to install packages, where to get the Excel data that you need to complete the labs, how to run and interpret the two-way ANOVA, how to get and interpret effect size, how to run and explain pairwise comparison test, how to do an interaction plot, and how to report your results in APA style, as well as how to run a chi-square test, how to explain those results, and how to report in APA style. So, first things first, we're going to need two packages to start off. So you're going to want to use install.packages, parentheses LSR. We'll just go ahead and run. And you see red text pops up and then successful. We're going to do the same thing with another package called Descriptive Tools, DESC TOOLS. So run. Those quotation marks are very important to make sure that they're there. All right. Next thing that we're going to do is we're going to import our data set. So looking at Lab 1, you see that it says we need career Excel sheet. So you can go into Blackboard and get both of the data sets that you need. And we're going to go click Import Dataset from Excel. And then wherever you downloaded it to, you're going to upload it from there. So the first one we're operating with is Career. You can rename it to something else to make it shorter or easier to read. For this data set, you don't need to do anything with the different data columns. It should load exactly as it needs to in order to function properly. So we click through those different menus, and you see that it automatically creates the blue text that we need and automatically displays the data that we just uploaded. So we're going to go back, and we're now at the point where we need to make some of our variables factors. We have two factors, and that's what we're considering here. So you can read in the ANOVA, it says, using the Excel to examine if there's a main effect of age and gender on income. Okay, so we're looking at age and gender and how they might interact to impact income. So the first thing we're going to need to do is we're going to make a factor that we're just going to call age. We have raw data right now, so you can just type in age or whatever you want to make the name of the factor. Age is just simple. And then you're going to define as factor, so as dot factor, parentheses, and I'm going to show you guys what happens. So if I do age, and I'm doing the little pointy arrow, you can also do the equal sign if you prefer. You see as factor, as you start to type it pops up, you can click it, puts the parentheses there for you. If you put career, after you type a few letters, it starts to pop up. Make sure you're referencing the correct one. I have two different versions of career in here, but I only need this one. And specifically, I'm just concerned with the age column, right? And then make sure you hit run. And now you see over here in the, actually it's not showing up in the global environment for some reason. Oh, there it is. You can see values. Age is a factor with 4 levels. It says what the names of the levels are, 1, 2, 3, and 4. And then it kind of just has a count. We're going to do the same thing with gender, and it's going to work exactly the same way. Gender defined as factor, parentheses, career, $, gender. And that is basically just defining that column as gender. So now we're actually ready to perform our ANOVA. So whatever you want to name your first ANOVA, in this case, I have it here as Lab 7 Question 1. And you're going to define that object as AOV, analysis of variance, parentheses, and there's 2 different options. This one is the shorter option, but it might be less clear to you about what to do later on when you have more complicated, say a 3 or 4-way interaction you're trying to take a look at. Might be really confusing. But for just the simplest way to do an ANOVA is to just use a little star in between the 2 factors that you want. And then parentheses, not parentheses, comma, data equals, and then this is the career spreadsheet. So I'm going to type this out so you guys can see what happens as I type it out. Lab 7 Q1 defined as AOV, excuse me, income. You'll see after I type a few, I guess not, it's not going to pop up. Income, you use this little tilde thing that's right beside, that's shift, and then the character beside your 1. Age, star, gender, right? And these are the things that we defined already. Data equals, and then career, which is the name of the spreadsheet that we referenced already, right? The longer way and the more official way is to type out each thing individually. So do age plus gender plus age times gender. You're looking at age and gender and then the interaction of age and gender, right? So, and then we want a summary, all right? And you see we get our results down here. So let's talk about our results very quickly. You see for age, it's got your degrees of freedom is shown, that there's 3, which means that there's 4 different age categories, right, in -1. Degrees of freedom for gender is 1, which means that there's 2 genders, male and female. Both of those were significant. These 3 stars means that it's significant at the 0.001 level, right? Now, this is age crossed with gender. You see the degrees of freedom is 3 within that. And then it's got this single dot over here. That single dot references 0.01, which is greater than, sorry, not 0.01, it's just 0.1, which is greater than 0.05, which is our minimum alpha level, right? That's what we're usually looking for. And if you're confused about that, you can look here and you can see this number, 0.09, is bigger than 0.05, which means that there wasn't a significant interaction. That means that basically there's differences between ages and there's differences between genders, but it's not more or less different based off of how gender and age interact, right? Those differences are kind of systematically about the same across both genders and across all ages. So, we're going to go ahead and we're going to take a look at the effect size. So first thing is you're going to want to make sure that you've got LSR active. And you just do library LSR to make sure it's active. And this will allow you to do an eta squared thing. You just type in eta squared, and I'll show you here. If you just type in eta, it pops up, and it even shows you right here it's attached to the LSR packet. And then since we already defined our object as the ANOVA results, this will interpret our eta squared statistic for us. So we're going to hit run, and we can see here you've got your full eta squared and your partial eta squared. So I'll show you guys later on what that actually looks like. But this is our results so far. This is where we're at. You can see the partial eta squared is going to be 0.09 and 0.07 for age and gender respectively. All right, next thing we're going to do is we're going to use descriptive tools. So we're going to make sure that's active by doing library parentheses descriptive tools. And that will allow us to do the post hoc test. So all of these things are important here, and so I'm going to describe it a little bit. Right, so we're doing a post hoc test, and you see that it pops up as an option. All right, we know that we need to reference the same thing, our ANOVA results. So now we're going to do method. And you see method equals what we're going to use, and the only one you need to know is Bonferroni. This is like the bread and butter approach. So next thing, we need to define a confidence level. And you're just going to use 0.95 as your confidence level. Make sure you type in that 0. Make sure it's typed in exactly like that. And then ordered, it's just asking us, do we want this ordered? We're going to say no. You don't have to understand what that means right now. Just say false, right? And then run. So you get this monster of a few different charts, and they're a little bit hard to see and understand. So let's explain it. So first thing, you've got the $age, and then what it does is it compares each individual level to each other individual level, right? So a few things to note here that are important. So you see all of the differences, all of them are different from 1, right? There's a statistically significant difference between all the different factors and level 1, which is going to be our youngest age group. For the purpose, I think the official thing for this was like 18 to 29, but you can just say people in their 20s, right? So basically, all of the older age groups got paid more than people in their 20s, right? And that was statistically significant, the most statistically significant. You see this right here where it's got the difference scores, right? So you see there's a little bit of difference between age group 2 and age group 1, but there's a bigger difference between 3 and 4, right? So unless people in their 20s somehow get paid more in general or get paid the most compared to everybody else, then they have to get paid the least compared to everyone else. And that makes sense. So basically what you're kind of seeing here is that the youngest age group, 1, gets a little bit of a pay increase as they move into the next group, so into their 30s, which is 2. And the highest difference of all of these numbers here is between 3 and 1, right? So that might be having you thinking, well, does that mean people get a pay cut when they move? So let's say it's 20s, 30s, 40s, and then 50 plus, right? Your 20s, your 30s, your 40s, and then everyone 50 plus. So you can see we're going to kind of get a little bit more information from these other comparisons here. So looking between 3 and 2, there is a statistically significant difference, and it's in the same direction. So basically, people get paid more, and they get paid more, moving from 20 to 30, and then 30 to 40. But you see that there's not a statistically significant difference between people in the oldest group between 2 and 3, which means that even though there's a pay drop that is very, very slight, statistically it's not significant, and in fact it means that people who are above 50 aren't really paid different between those in their 30s or those in their 40s, right? So it's kind of confusing, but we're going to need to know that when we write our description. And then look here at gender, and you see there is that gender difference. And we honestly don't need this table other than to know that if you take group 2 and you subtract group 1 from it, you get a negative number, which means that if group 2 is female and group 1 is male, female score minus a larger male score equals a negative number, right? Now, if this was coded the other way, then we'd have the opposite interpretation. But usually put male as 1 and female as 2. That's just like a really old convention, and that's just what people continue to do. So yeah, we have the directions of our differences now. And because there was no interaction, we don't have to do too much more. So let me pause this and I'll show you guys the Word document now.